by Özgür Karaoğlu, professor at the Geology and Volcanology at Eskişehir Osman Gazi University, to discuss the ongoing seismic activity near Santorini Island in the Aegean Sea. Mr. Karaoğlu, thank you so much for joining us here on A News.
Thank you. First of all, thank you very much for your kind invitation. Thank you very much.
Thank you. Let's talk about what is going on in the Santorini region. What can be said about the origins of the earthquakes in the Aegean Sea? What would you say about that? And do they have any connection to the melting ice in Antarctica and the fault line movement?
Yeah, it's very challenging issues. As we are all aware, an intense seismic swarm has been occurring in the Aegean Sea since end of January in this year. And the seismic activity characterized by hundreds of seismic events per day exhibits an ellipsoidal distribution extending approximately 50 kilometers from the northeast of this Santorini volcano. In this region, the northeast trending faults that control the submarine Amargos and Anisros basins are well known as the primary source of many tectonic earthquakes in this region. Typical earthquakes resulting from fault-controlled block displacements occur along these structures. However, the current earthquake distribution does not strictly align with known faults. Instead, it forms a distinct ellipsoidal pattern. Particularly noteworthy observation is that these earthquakes predominantly occur within the upper 10-kilometer crust and with a concentration at approximately 7-kilometer depth. Actually, until a few days ago, it was widely believed by our Greek colleagues that these earthquakes were directly controlled by tectonic forces, but many scientists now are offering views that these earthquakes are directly related to magma movements. Regarding the other question, yes, recent high-quality studies have demonstrated a link between glacial melting and the acceleration of magma production. So how can we explain this one? The removal of an ice sheet reduces the overburden pressure, and this results in additional decompression melting in the mantle. The associated stress changes in the crust facilitate magma propagation to the surface, thereby increasing volcanic activity. The effects of concomitant sea level changes on volcanic activity, however, have not yet been firmly established, because sea level change is a worldwide phenomenon, and the majority of the Earth's volcanic systems are located in or next to the ocean. The fact is of great global concern. Regarding the Santorini linking, in addition, a study of Santorini's over 300,000-year eruption record compared with sea level change reveals that when sea levels drop 40 meters below the present level, tensile stress in the magma chamber roof initiates dike injections, meaning magma propagation. Further drops to 70 or 80 meters allow dikes to reach the surface, and triggeric eruptions while rising sea levels above 40 meters suppress volcanic activity.
Well, when you explain it like that, you have mentioned the magma movement that is happening near the Santorini, but could you also explain how does the magma actually move, and does it always trigger a volcanic eruption?
Previous studies using seismic tomography, widely employed to detect melt accumulations, have already identified the presence of magma reservoirs within the crust in this area. The hybrid nature of the seismic activity in this region, its spatial distribution, and the prior geophysical and oceanographic research strongly suggest the potential existence of magma storage beneath this region. In addition, I anticipate that more definitive evidence concerning magma chambers will emerge in the coming months following a comprehensive analysis of the recent seismic data by seismologists and volcanologists. In my view, while some of the earthquakes are clearly controlled by tectonic faults, I believe the majority, particularly those with magnitudes of 3 and below, are induced by the lateral and vertical emplacement of magma within the brittle upper crust. Although the recent seismic swarm has not occurred directly beneath the Santorini's Columbus submarine volcano in here, but the proximity of these earthquakes to the region suggests a potential increase in stress accumulation around the magma chambers beneath both volcanic systems. The stability and relative immobility of these magma chambers, located approximately 5 kilometers below the surface, are maintained by a critical pressure limits. When this pressure exceeds 2 megapascal, the system may reach a critical point, potentially leading to the onset of magma propagation as dike or seal swarms. And this means these one are magmatic intrusion packets from the magma chamber. But if excess pressure suppresses 4 megapascal, it's highly likely that magma may begin to escape toward the surface in significant volumes. Consequently, it's evident that this seismic activity could contribute to the build of excess pressure within the magma chambers, increasing the likelihood of future magmatic unrest. In other words, the continuously deforming Aegean crust may not only be experiencing tectonic strain, but could also be primed for magmatic activity in the near future.
Well, the eruption of the Santorini, let's talk about that as well. Of course, we are talking about so many scientific details about the situation, but let's talk about a little bit talks that is speaking, people are speaking on the streets as well, because the eruption of the Santorini, they are saying that it may particularly affect the other regions, considering we are, as Turkey, a part of the Aegean placement. So do you think that it could actually affect Turkey in any way? And what would be the ecological consequences for marine life in the Mediterranean Sea also?
Yeah, this is very important. So it must be emphasis from the outset that this entirely plausible eruption scenario may vary depending on the gas content, chemical composition, and volume of the magma. If the rising up magma is rich in gas and has a substantial volume, its interaction with seawater, it's likely to produce an explosive eruption, potentially generating a high altitude eruption column. The greater the height of the eruption column, the more efficient the volcanic material can reach the stratosphere, where wind and atmospheric currents could transport ash and aerosols hundreds of kilometers away. And alternatively, a low volume gas-poor magma eruption may occur. In such a case, the impact would be largely confined to the immediate vicinity of the volcanic vent, posing a more localized hazard. So how have volcanoes in this region behaved in the past? Unfortunately, security records indicate that high-volume, gas-rich explosive eruptions have usually occurred in this region. If future eruptions match the intensity of these past events, pyroclastic fallouts and widespread ashfall could reach to our coastline. Of particular concern is the potential for volcanic ash to interact with rain clouds, which could lead to formation of, unfortunately, acidic rain. In such a terrible scenario, agricultural and livestock activities in coastal regions of our country may be severely affected. Continuous monitoring and some in situ measures will be crucial in mitigating the potential hazards associated with future eruptions. Although marine ecology is negatively affected in such cases in short periods, when considered in the long term due to the abundant mineral material flowing in the sea and increasing temperatures, it also leads to the explosion to the many diversity. It's very interesting.
Well, it is interesting, and it is for sure that we are seeing that the world is changing with the climate change, with everything that is happening underneath the surface of the world as well. Every day we are seeing a change and we are seeing a reaction from the nature. Lastly, what would you say about the comparison between the Santorini and the Indonesia likelihood of the eruptions of the volcanoes? Do you think that, I know that they're so far away within each other, but do you think that they're resembling one another?
Yeah, although that volcanoes were formed, for example, Etna volcano is recently we observe Etna's eruption. Both volcanoes were formed as a result of similar subduction processes. Their eruption frequencies differ significantly. Mount Etna, for example, experiences frequent eruptions with lava flows occurring almost annually, while explosive volcanic activity remains relatively rare. In contrast, the volcanic activity for example, at Mount Etna follows a much longer time scale, with eruptions occurring every few centuries. However, due to the influence of the surrounding water environment, these eruptions tend to be highly explosive. We can say that.
Well, Professor Dr. Özgür Karaoğlu, who was joined us from all the way Turkey's Eskişehir province. Thank you so much for joining us here on A News. We're hoping to see you again soon.
Thank you very much.